Okay, can you hear me?
Can teacher?
Can you see the screen?
Yeah.
Okay, right. So today we are going to see how to find the turning points and how to determine the type of turning points. We are not going to determine this type, the point of inflection, no. We are going to determine the minimum point and the maximum point to decide whether it is maximum or minimum. Okay. First of all, I go through we have what I have told you yesterday. Right? What I've told you yesterday. Okay, right. First thing, right. This curve shows a minimum point A, minimum point A, and the gradient changes from negative to positive. So this is the characteristic of minimum. Gradient changes from negative to positive. Now, at the same time, we also know that as the gradient changes from negative to 0 then to positive, it means that the gradient is increasing. So the increasing, we can say that the rate is positive. The rate is positive. So when you look over here, okay, when the A is increasing, okay, the gradient is increasing, then the rate of change of gradient with respect to x is positive. Rate of change of x is d2y dx square. So d2y dx square is positive. Okay, then we look at the second type of turning point. There is this B, right? B. Okay, as the point approaches B, the gradient is positive. Then you go further and further from the left to the center, it becomes 0. Then from 0, it becomes negative. When it goes to the right hand side, it becomes negative. So in other words, the gradient changes from positive to negative. The point B is a maximum point. Point B is a maximum point. Okay, right. And if you look at the gradient from negative, it becomes 0. Then from positive, it becomes 0. Then from 0, it becomes negative. So we say that the gradient is decreasing. Decreasing, right? Okay. If the gradient is decreasing, right, then we say the rate of change of the dy dx is negative, because dy dx decreases as x increases. X always increase because we move from left to right, from a smaller value to a bigger value. Right? So it is always increasing, but we have to look at the gradient, whether the gradient is increasing or decreasing. Okay, next page. Oh, I have to hide the others first, right? So we look at this question here. Question number 1, exercise 2.10. Now, there are many questions here. Some, they are very simple polynomial, so you can differentiate them easily. Uh, this one, you look at C. Now, C is quite, here, you look over here, the question here. C is, you cannot differentiate them like a simple polynomial, right? You have to use the uh, product rule. Not only you use the product rule, but there's a square root here. You have to use composite function or the chain rule, right? So this type, you can find dy dx easily. But if you want to find d2y dx square, the second derivative, because there's a square root there and you differentiate it 2 times, it will become very difficult. So this type of question is not suitable to use the the second derivative, because it's quite difficult to find the second derivative. So I use the analysis of gradient to do this. But if you look at question G, question G, y equals to x plus 1 over x minus 1. Now this, although it has a negative index here, but there is no fraction. To find the first derivative and to find the second derivative, they are easier, right? Easier. So for question G, I'm going to show you using the second derivative. Okay. Okay. So this question we use the second derivative because it is easier to find the second derivative. Right. Now this question I use analysis of gradient because it is more difficult to find the second derivative. Okay, now so you know when you look at the question given to you, you must know which method is easier. Sometimes analysis of gradient is easier, sometimes second derivative is easier. Okay, right, we start with question 1c. Y equals to x square root of 18 minus x squared. Okay, this one I'm going to differentiate using the uh, product rule. So differentiate 1 and this square root, I just keep it. Now the second time, this x I cannot differentiate, I differentiate the square root, bring down the half, 18 minus x squared, then half minus 1 is negative half. Okay, negative half. Then differentiate what is inside the bracket here, negative 2x. So it is negative 2x. So the differentiation part settled, right? So now we try to simplify. Simplify, this one can be expressed as this thing over 1. Then the x square, you can put at the top. Negative 2 and positive 2, they cancel, but the negative sign is still there. Then this term I put below here. Okay. The simplification part, is it okay or not? Okay. Then I cross multiply. Multiply this one towards this side, and you have the square root disappear, because square root multiply with square root, the square root disappear, become 18 minus x squared. No more square root. Then minus x squared, the original numerator. So denominator is like this. So I try to simplify by factorizing. This 18, I take out 2, becomes 9. Negative 2x squared, take out 2, become x squared. Take out 2, become x squared. Okay, right. So this is the dy dx. This is the dy dx. Now, if you want to find the turning point, you must put the dy dx equals to 0. So I write here, for turning points, dy dx is equals to 0. dy dx is equals to 0. So this is how we're going to find the turning point, by putting dy dx equals to 0. So this is your dy dx, and you put the dy dx equals to 0. Now when you put the dy dx equals to 0, this dy dx consists of two parts, one at the numerator and another at the denominator. Now I want to tell you that if you see this type of function, only the numerator is 0. The denominator you don't put equals to 0. Okay or not? One more time. You see two, of course you want to say two functions, yes. You see that the numerator is one function, the denominator is another function. Now when you say that this whole thing is equals to 0, it doesn't mean that the top is 0, the bottom is 0. No. No. So only the top part is 0. Now why the bottom is not 0? If the bottom is 0, then you will get infinity. You won't get 0 there. Or you get undefined. You won't get 0 there. So this function will be 0 only if the numerator is 0. The denominator can be anything. So you don't equate the denominator equals to 0. So now I put the numerator 0. 9, 2 bracket 9 minus x equals to 0. Okay. So this 9 minus x square can actually, this 9 minus x square can actually factorize into 3 minus x, 3 plus x equals to 0. The 2, we divide by 2, then it disappears. Then you have two values for x equals to 3 and x equals to negative 3. Okay, so we have actually 2 points, two turning points, one where the x is 3 and another negative 3. Okay, I stop here first. Any question? Any question?
Teacher,
Yes.
for the 1C, when we differentiate the bracket one, wait, this one,
Yes.
this one we just copy down from the up,
uh, the one, the x you differentiate become 1, then this thing you just copy down the same. You differentiate 1, then you keep 1. So in the
Okay.
second part, you keep this one, the x here, you don't differentiate. Then you differentiate the square root.
Okay, okay.
Okay. I want, do you know what to do here, over here? Turning point dy dx equals to 0. Do you know what to do?
Yes, teacher.
Ethan, know what to do? Okay, so once you differentiate this thing, differentiate the y, you get the dy dx, put the dy dx equals to 0. When you put the dy dx equals to 0, when you put the dy dx equals to 0, then only the top part is 0. Any function at the bottom, not 0, right? Only the top is 0. And when I put 0, I get two values for x. Okay, for each value of x, I try to find the value of y. So this x equals to 3, I substitute back into y here. I substitute back into y. Don't substitute into your dy dx. Because if you substitute into your dy dx, you get 0. Because your x come from the dy dx. You put back inside the dy dx, you get 0. So the value of x you obtain here, you substitute into y. Okay, so substitute into y and simplify, you get 9. You get 9. Okay. Then the negative 3 also substitute back into the y. Don't substitute into dy dx, right? Substitute back into the y, and here negative 3, and here also negative 3. So you end up having negative 9. So we have two pairs of values, x equals to 3, y equals to 9. I copy down at the bottom here. X equals to negative 3, y equals to negative 9. I copy down here. So I say that the turning points are 3, 9 and negative 3, 9. Negative 9. So do you know how to find the turning points or not so far? Do you know how to find the turning points? If you know, then we
Teacher,
carry on. Then after I come back, explain one more time
teacher,
so that it goes into your mind.
teacher,
Yes,
why the tree right in front the square root?
because there's an x here. You see this x here?
Hmm?
Okay, I copy down this. Actually, it comes from here. Wait, edit, copy. I put it here. Edit, paste. So actually, I substitute inside here. This x equals to 3. I substitute inside the y. So here 3, the 3, this 3, this 3 is actually from the x. This 3 is actually from the x here. Okay, so I substitute inside the y to find the y coordinate of the turning point. What I get from here is the x coordinate of the turning point. What I get from here is the x coordinate of the turning point. Okay, so I try to substitute back. Substitute 3 here, and here also 3. If negative 3, then I will substitute in negative 3 and get the value of y. So for each value of x, I try to get one value of y, because coordinates, they come in pairs, one x and one y. So for each value of x, I find y. For the other value of x, I find y. Okay, right. So I match them together, and create a point. I match the second pair and create a point, another point. Okay, any more question? Okay, good. No question. So now I have found the two turning points. You see the type of question that we are having here is find the turning point, determine the type of turning point using analysis of gradient. Now, analysis of gradient is like this. Now, let's say we look at this point, 3, 9. So here is 3, 9. Can you see on the graph here, this is 3, 9? Okay. Then you choose a point on the left of the turning point. You choose another point on the right of the turning point. Now, it's up to you which point you want to choose. So I choose 2.9, which is slightly smaller than 3. And I also choose 3.1, which is slightly bigger than 3. Then for this 2.9, okay, for this value 2.9, I try to find the gradient, the dy dx. For this value 2.9, I try to find the gradient dy dx. Then for this value 3.1, I try to find the dy dx. I want to know whether the dy dx changes from positive to negative or negative to positive. So this is what I'm going to do, right? Okay, so I want to analyze the gradient at the point 93. This is my point 93, right? Over here, 93. So in order to get the gradient at this around this point 3, I take 2.9 first. You have to take the smaller value first. So this 2.9, I substitute into the dy dx here. So 2.9, this is my dy dx, right? This is my dy dx. 2.9, substitute the x 2.9 here and the x 2.9 here at the bottom, at the top and the bottom. Okay, right. So when I substitute 2.9 at the top here, okay, 2.9. Now 2.9 is less than 3. Okay or not? So if it is 3, then 9 minus 9 will be 0. But this is less than 3, so it is less than 9. 9 minus a number less than 9. Is it positive or negative?
Positive.
Positive. So you don't have to actually calculate the actual value. So you just look at it and you see, oh, 9, then this one, 9, if it is 3, 3 square will be 9. But this is less than 3, is 2.9. So 9 minus a number of 2.9 square, 9 is definitely bigger than 2.9 square. If it is 3, then it will be equal to 9. But if it's 2.9, it will definitely less than 9. The square will be less than 9. So it will be a positive number. So I don't have to calculate, I just say positive. Is that okay? Is that okay?
Okay, teacher.
Qian Tong? Qian Tong okay ah? Can. Okay, right. Then I try the other number, 3.1. Okay. Qian Tong said okay. So I try the other number which is slightly bigger. Now you may ask me, can I choose 2.8 and 3.2? Can. Okay, it's up to you, right? But don't choose too far away. Too far away, then you may exceed the other turning point, then you get all the wrong one. If some value very near, then it is okay. So if I substitute in 3.1 into the x square here, what do you think 9 minus 3.1 square be? 9 minus 3.1 square, what will it be?
Negative.
Negative, correct. Because 3, if it is 3, then it's equal. Right? But if it is more than 3, then it should be more than 9 already. So it will be negative. So I write down negative. Meanwhile, at the bottom here, I don't encounter this type of problem. Why? Because the number in front is not 9. The number in front is 18. So it will definitely be positive. Okay or not? At the bottom there, you won't get a negative number. Is because at the bottom is 18, it is not 9. Okay, so now I see the gradient changes from positive to negative. It is this part. 2.9 is like this, positive. 3.1, it is negative. Right. So this shows that the dy dx changes from positive to negative. So 3.9 is a maximum point. So we look at the other point. We look at the other point. We look at the other point. Where? This one. The other point is -3, -9. So the -9, you don't have to look at it because the -9 is the y value. We want to look at the x value. Now, -3. Can you tell me a number which is less than -3? -2.9, is it less than -3? Yes or no? No, right? The smaller number will be -3.1. You look at this part here, right? You look at this part here. You look at this part here. -3, -3.1 is on the left. -2.9 is on the right. Then you go nearer and nearer, and this point will become 0, right? 0, then 2.9, 3.3, 3.1. So the smaller value now is -3.1. It is not -2.9. Is that okay or not?
Yes, teacher.
Okay, right? Okay. So the smaller value is 3.1. So I'm going to use this -3.1 and substitute it into the equation. Substitute into the dy dx here. Now -3.1, when you square it, it becomes positive 3.1 square. And 9 minus positive 3.1 square, what do you think you will get? A positive number or negative number? The -3.1, when you square it, it becomes positive already. It becomes positive already. Then the negative is still outside there. There's one more negative outside. So what do you think? This is positive or negative? If you don't know that much, you just use your calculator, right? Just use your calculator, and it becomes a negative value. Negative value. So when it is 3.1 here, 3.1, the gradient here is negative value. Here, right? Actually, this one is very near one, but I just draw it very far away. Actually, this one is very near here, like that. Near here. But I just draw it a bit further away lah. So that it's quite clear. If all the thing I draw very near, then it becomes very not very clear anymore. Okay, right. Uh, can I go on to the second value? Now the value on the right, the value on right is -2.9. -2.9 is bigger than -3. So when I substitute -2.9 into the dy dx, if you cannot see that it is a positive number, never mind. You just use your calculator, right? Use your calculator, and you see that it's a positive number. And the dy dx changes from negative to positive. Negative here, negative, and you look at the graph here, negative to positive. So negative to positive. it is a minimum point. So I say that this point, -3, -9, is a minimum point. Okay, so now, so I repeat, before you ask me any question, I just repeat for your sake. Okay, uh, I'm going to repeat, right? Okay, now the first thing that you need to do is, when you want to find the turning point, is you find the dy dx. Make the dy dx equals to 0. So when you make the dy dx equals to 0, sometimes you get only one value for x. Sometimes, depending on the equation, you will get two values for x. Or whether you get one value or two values, you have to test whether what type of turning point they are, whether they are maximum or minimum, right? So in order to do that, I use the analysis of gradient, because for this dy dx, if I'm going to find the d2y dx square, it's going to be difficult, right? It will take quite some time. So I don't want to find d2y dx square. So I just take the same dy dx here, I test it. Okay, how to test it? Now, the first point, 3, 9. Okay, 3, 9, I take a value smaller than 3, I take a value bigger than 3. Always smaller to bigger. Don't bigger to smaller, then everything will be wrong. So you follow the steps closely, correctly. Take a smaller point, substitute inside the dy dx. So the smaller point, substitute, you get a positive value. Bigger point, you substitute, you get a negative value. So from positive to negative, it is a maximum point. And you have to write out, you have to write out these things here. Dy dx changes from positive to negative is a maximum point. You have to write this out. Don't write out, then the people don't know. You don't just put there, oh, this is positive, this is negative. At least you must say from positive to negative is a maximum point. Okay, the next part, I choose the other point. Sometimes you have only one point, but if just in case you have 2 points, then you look at the second point, you do the same thing. Take a smaller value, then take a bigger value. Jangan terbalik lah. Terbalik, then everything will be wrong. So we start from a smaller value, -3.9, substitute into dy dx, use your calculator, try to find out whether it's a positive or negative number. If it is a positive number, then you write down positive. If it's a negative number, then you write down negative. Then choose a bigger number. Use this bigger number, substitute into your dy dx. Use the bigger number, substitute into dy dx, and see whether you, from your calculator, see whether you get a positive value for the dy dx or negative value for the dy dx. Now, whether it is positive value for dy dx or negative value for dy dx, you don't have to know how to draw the graph. You just see, oh, it changes from negative to positive, negative to positive, so it is a minimum point. It's a minimum point. Okay, so I have gone through the process 2 times with you. Any question?
Teacher,
Yes.
if they ask this question, we need to draw out this graph.
No need to know how to draw the graph. You just pretend that you don't know the graph, right? Substitute, find the point, take one smaller value, substitute, take one bigger value, substitute. That's all. Then
Okay.
from your calculation, you determine whether it's maximum or minimum. Now I draw out for you to see, because it's easier for me to explain. And this software, Geometer Sketchpad, can draw out everything for you. Now if you want, then I pass the program to you, then you can always draw it yourself. Even when you go to Form 6, or whether you go to college or what, you can still use this program. It's given by the government. The government bought the program from America and distribute it free for every student in Malaysia. You see, when you open up the time, they have the logo Kementerian Pendidikan Malaysia, right? You see that content, what's new? This one. No, this is not, right? There is a logo there. Okay, never mind. Okay, so this one okay or not? Okay, then I go on to the second method.
Okay, teacher.
Okay, right. So we look at the second method. Now this method, I want to find the dy dx, right? So differentiate x become 1. Differentiate this, you have to use the chain rule. You have to use the chain rule, okay, or composite function. So this is -1. The power is -1. Bring down -1, and the power become -2. Differentiate inside, it become 1. Become 1. So this is your, you simplify this, the negative you put in front, -2 you put at the bottom. So this is your dy dx. Now, the first thing, find the turning point. To find the turning point, you put dy dx equals to 0. That means you put this thing here equals to 0. So 1 over x square minus x minus 1 square equals to 1, because negative bring over become positive. Okay, then I flip over from the top and bottom terbalik. So this one become x minus 1 square. The other side also become 1. 1, no matter how you flip, it become 1 also. Then I take square root. Square root on the left hand side become x minus 1. Square root on the right hand side become positive or -1. So when you take square root, you have to write down positive or negative. Okay, right. So x minus 1, if it is positive 1, then the x is 2. X minus 1, if it is -1, then the x is 0. The x is 0. Okay, so x equals to 2, I substitute back into the y here. I substitute back into the y here. Okay, where is it? I substitute back into the y here, and it becomes like this. Okay, the 2 become 2, 2 minus 1. This is 2 minus 1. Simplify, become 3. Then I substitute 0 into the x here, become 0. Substitute 0 here, become 0. So overall, it become -1. So I have two pairs of values here. One is 2, 3. Here 2, 2, 3. And I create one turning point. Then another pair is 0, -1. I create another turning point. Another turning point. Okay, right. So how to determine which one is maximum, which one is minimum, without knowing how to draw the graph? Without knowing how to draw this graph, we are not required to know. I just draw, as I've said, I just draw this to show you, to explain to you only, right? To explain to you. Okay, so far any problem with finding the turning points?
Teacher,
Yes.
you say you terbalik the 1 over x minus 1 negative to the power of 2, but then if terbalik the inside the minus no need to become plus ah.
No need, unless you are multiplying, no need. If you, if it's addition or subtraction, then you move here, move there, then you need to change the sign.
Okay,
Like
okay.
here. Now you see here, negative mah. When you come here, become positive, because I move from one side to another side. Then you have to change the sign. But if it's multiplication and division, then no need. When you terbalik, it's actually division. Division. So no need to change the sign.
So terbalik is don't need to change the subtract the
Ah,
plus or the minus lah.
or
It's
when you
like
cross,
from
yes, or when you cross multiply, the bottom here you cross to the other side, bottom you cross to the other side, the center is equal. No need to change the sign, unless the whole thing you move like that. don't
okay,
don't
okay,
terbalik.
understand.
The whole thing you move like, then it become negative. You move to the other side, it become negative. Okay, any more
Okay.
question? Okay, right. So the next step is to find d2y dx square. Did I show how to find d2y dx square? Or I didn't show how to, oh yeah, now I'm showing you how to find d2y dx square. So your dy dx is here, dy dx is here, right? dy dx is here, right? So when you differentiate 1 becomes 0. Now this thing, when you differentiate, the negative sign is still here. This negative sign is still here, right? Then this one is negative 2. So I bring down negative 2. Negative 2 minus 1 become negative 3. Negative 3. Then differentiate inside is 1. So negative negative become positive 2. And this thing I bring to the bottom, x minus 1 cube. Do you know how to find the second derivative? This is the first derivative. I am finding the second derivative here. Oh, let me write down again. Alamak, cannot leh. Okay, let me write down. 1 minus x minus 1. X minus 1. Then to the power of, this one is to the power of 2, negative 2. To the power of negative 2. Okay, right, it's something like this. Okay, so I differentiate this thing, differentiate this one, bring down the negative 2, then the negative 2 become negative 3, then differentiate the inside become 1. Okay, so it's like this, right? So yeah. So now I simplify, bring back the 3 at the bottom here, it become 2 over 1 minus x to the power of 3. So this one is very easy. Second derivative is very easy. Then now you don't have to find a point smaller than 2, a point bigger than 2. No, straight away you take the value of 2, you substitute inside the d2y dx square. Okay, this 2 you put inside the d2y dx square, and the d2y dx square becomes a positive number. So positive number lah, you remember it's a positive number. Then I take 0, the answer here, the turning point, 0, I use 0 directly. This one, you don't have to substitute 2 times. You don't have to choose a value smaller than the x and a value bigger than x. No need. Use that point, the turning point itself. Substitute inside the d2y dx square. So 0 substitute inside here becomes negative 1. 2 divided by negative 1 is negative 2. So this is a negative number. So the the point is 2, 3. 2, x equal to 2, the actual point is 2, 3. And it is a positive number, then we say it's a minimum point. Then the 0 is actually 0, negative 1. So 0, negative 1, and the d2y dx square is a negative number. So it's a maximum point. Okay, so you ask questions first, then I go through the thing again.
Teacher,
Yes,
the d2y over dx square come from where?
come from the dy dx. You differentiate this dy dx again.
Uh,
Differentiate the dy dx, you get d2y dx square. Then substitute numbers inside the d2y dx square. The number from the turning point.
okay.
Okay. Any more question? So today no second session, Aline.
Yeah, teacher.
So that's all lah. Okay.
Yeah.
So next week, any lesson?
I think no, teacher.
No.
Because
Yeah.
then.
When got lesson, you tell me.
Okay, teacher.
When there's lesson, it's coming to an